The Northeast Corridor, the busiest rail line in the US, runs from Boston to Washington, D.C. With no redundancy in the system, disruptions can cause major issues, and one key choke point is this bridge over the Connecticut River. Over a century old, this bridge struggles to keep up with increasing train traffic and suffers from frequent electrical and mechanical failures. To address this, a new bridge is being constructed to support higher train speeds and larger maritime traffic. Set to cost around $1.3 billion, the project has raised concerns over its cost effectiveness, with a significant portion funded by federal taxpayer dollars. While modernization is crucial, especially for US rail infrastructure, the question remains, is this hefty investment justified given the line's usage and broader infrastructure needs in the US? Let's explore the details and implications of this massive project. The existing Connecticut River Bridge, completed in 1907, was a cutting-edge engineering feat at the time of its construction. It was built for the New York, New Haven, and Hartford Railroad, and replaced an aging single-track bridge from 1870, which had been rebuilt in 1889, but couldn't keep up with the increasing weight and frequency of the trains. It stood relatively unchanged until the late 20th century, when it saw some restructuring and electrical rehab. The bridge itself, as mentioned, spans the Connecticut River. It's a 10-span, open through-truss steel bridge that's approximately 1,570 feet long. At its heart, the bridge features a 160-foot-long bascule span, a movable section that uses a counterweight system to raise and lower, ensuring smooth passage for maritime traffic below, or basically just a fancy word for a drawbridge. The bridge's substructure consists of 2 stone masonry abutments and 9 piers. Today, it supports 2 electrified rail tracks carrying over 50 trains daily, from Amtrak and commuter services to heavy freight locomotives, keeping a vital transportation artery in motion. But as classic and important as it's been, the bridge has gotten older and older, and its reliability is quickly decreasing with age. In 2000, a major electrical failure left the bridge's drawspan stuck in the open position, halting rail traffic. The following year, it jammed twice in the closed position, further disrupting operations. But electrical issues weren't the only problem. A 2006 in-depth inspection highlighted critical issues, including the mechanical operating system and structural connections on the approach spans. Cracks were found in the track, tread structure, and supporting steel. Additionally, a system added during the 1990s electrification project significantly increased weight on the bridge, straining both its aging design and counterweight balance. And with periodic repairs no longer enough to maintain its century-old functionality, it was time to find a better solution. An environmental assessment published in May 2014 identified 2 preferred alternatives: a bascule bridge of similar size to the existing span, or a vertical lift bridge with potentially higher clearances, perhaps similar to the interstate bridge connecting Washington and Oregon, which I recently covered. Both options would be constructed on a parallel alignment just south of the current bridge. High-level designs without movable sections were rolled out due to the extensive approaches required, which would significantly impact nearby wetlands and increase both construction and land acquisition costs. As of recently, the world was able to see the officially chosen new design for the bridge. The new bridge will feature a 204-foot-long steel truss movable bascule at the span. Because it is over 40 feet longer than the span it replaces, it can allow for additional, potentially even larger maritime traffic to safely pass through. The new deck will be made of composite concrete, and the 9 steel girders holding it up will replace the existing stone masonry piers. One of the major benefits of the new bridge is the ability to handle increased train speeds. While the old bridge only permitted a maximum train speed of 45 miles per hour, the new bridge can handle up to 70 miles per hour. While this is certainly no bullet train, it'll help reduce passenger and freight travel time. Another benefit would be an increase in reliability. Theoretically, the new bridge shouldn't have any major electrical or structural issues, especially in the first few decades. The new bridge will be constructed 52 feet south of the existing one, so that maritime and passenger traffic feel as little of an effect as possible. Temporary bridges and platforms will be constructed along both sides of the rail on the east and west side of the river. A large embankment will be built up for the approach, as well as a much improved retaining wall. Once those are completed, the marine crews will use cofferdams to install the foundations, which are made up of drilled shafts and concrete. The 9 new steel superstructure spans will be installed after, which will be covered in the previously mentioned composite concrete. And potentially in learning from the tragic Francis Scott Key Bridge collapse from March 2024, a new steel fender system will be installed in the navigable channel. Due to the large amount of silt buildup throughout the river, massive container ships like the Dali would never use this channel. But it's still interesting to see how post-2024 bridge designs seem to include additional collision protection. Due to the size and strict construction requirements of the bascule span, it'll be built off-site at a facility in Florida, floated in on a barge, and then lifted into place to be attached to the counterweight in the rest of the bridge. Once this happens, the existing bridge will be demolished and all of the temporary construction facilities will be removed. The bridge construction process, considered phase 1, will last from late 2024 all the way into fall of 2028. Phases 2 and 3, which include the rail construction and tie-in, will occur in late 2028 and early 2029. And finally, the demolition of the existing bridge and the completion of the new fender system are expected to finish up in 2030. As I mentioned before, this project is far from cheap, leading some to believe that the cost-benefit is not quite there. To catch you up to speed on the funding portion, let's jump back to October of 2020. At this time, the Connecticut Department of Transportation and Amtrak were awarded just over $65 million in federal funding. This money was sourced directly from the State of Good Repair program, which was signed to upgrade rail assets, reduce backlogs, and improve passenger rail performance. In mid-2023, Amtrak applied for another federal grant. A few months later, it was awarded $827 million in additional money, which was entirely from the Infrastructure Investment and Jobs Act. Amtrak is expected to contribute an additional $148 million, and the state of Connecticut will be chipping in $58 million. And since the projected total cost is right around $1.3 billion, it's expected that Connecticut and Amtrak will be paying the final difference. Most agree that a new bridge is necessary, but given that 70% of the total projected funding, or nearly $1 billion, is federal taxpayer money, it raises concerns. While the project will likely benefit the US, it prompts questions about whether it delivers value proportional to its cost. The bridge is undeniably a critical choke point on the Northeast Corridor, but how does it fit into the broader needs of the corridor as a whole? At the same time, when the over $800 million chunk of money was announced for the bridge, the White House announced a $16.4 billion allocation for the Northeast Corridor, spread across 25 projects. While this represents a substantial investment, questions remain about its effectiveness. In 2023, 12.1 million passengers used the corridor, through a combination of Acela's high-speed trains and various regional services. And for those curious, Amtrak is a for-profit company, but the federal government owns all of its preferred stock, effectively making it a state-owned enterprise. And this distinction is important because, unlike private companies, such as those behind the sports stadiums that often receive surprising amounts of public funding, Amtrak operates as more of a public entity. While the US undeniably needs to modernize its rail infrastructure, which lags behind many other nations, the question remains, is this level of investment justified, considering the line's usage rates? I'll leave that for you to decide. Given that the groundbreaking ceremony was held in early September, the construction project remains in its early stages. As time goes on, you should be hearing more about the bridge, and of course that BuildCorp will be following it and providing updates, hopefully even when the bridge is set to be completed. I want to thank you for watching and give appreciation to you for allowing the channel to hit a monumental 20,000 subscribers. Back in January, the channel was under 2,000, and it's grown so much and reached millions of people. If you're new here, this channel covers the exciting engineering feats, uncovers unbiased financial realities, and explores the future of American construction projects. With that being said, thanks again, and I'll see you next time.